Hi, and welcome to this Software Engineering Day event, November 2021 in SimCorp. My name is Anders Hejlsberg. I'm the CTO of SimCorp. And with me today I have RUNGE, one of our development managers, and then a legend within the software industry, Anders Hejlsberg, who's also my brother. We invited him to come here today to talk about his present and his past within the industry. Mostly probably know him for C# and TypeScript. But we also invited all our employees here at SimCorp to submit questions, which is why we have papers here to make sure we get them accurately, to ask to Anders to get all these answers out of him. So Anders is, as I said, a legend. I've spent my childhood together with him, obviously, and computers was part of that. And nobody can be nothing but proud of what he's done. I'm really happy that you would like to spend the time with us today to answer these questions. Without further ado, Christian, I think you're going to fire up the first question.
Yeah, sure. And this one addresses both a bit of the past and the present. It says, you're the author of Turbo Pascal, architect of Delphi and C#, and currently engaged in the development of TypeScript. What has inspired you to work the programming languages, and what are your thoughts when you start designing one?
Yeah, I don't know why programming languages have had a special place in my entire career, but they have. I mean, I started, it's 40 years ago now here in Copenhagen. And well, actually, we started at our high school even before that in the late 70s. Our high school was one of the first high schools to offer students access to a computer. And of course, by modern standards, that was a doorstop of our computer, 32K of ferrite core memory, and whatever. But you sort of learned everything from the bottom up, and I was sort of always fascinated with how everything worked, and like the lower level workings of it. Like in the beginning, of course, when you get into it, you would write in back at that time, you'd write in BASIC, but that got kind of boring pretty quickly. And then I started writing in machine code because that's where all the power was, particularly at the time, if you wanted to squeeze something into 64K of memory. And then, I don't know, programming languages just had a fascination for me. It's a hard problem, you know, writing compilers, and it's not simple, but it's very satisfying when they work. And writing tools for programmers is very rewarding too, because they get very passionate about the tools they use, because they use them 8 hours a day, every day, and so, you know, little things matter to them, and so that's been very rewarding, I think, throughout my entire career, you know. Yeah.
So what thoughts do you have when you design a programming language?
Well, I mean, it depends, you know, on. I mean, in the beginning, I didn't really design programming languages. I implemented programming languages. Turbo Pascal was an implementation of a programming language called Pascal that had already been defined. It was as a successor of Algol and that family of languages. But I think for that, it was, I mean, Pascal was designed as a teaching language, but it lacked certain things that made it practical for real-world programming. So I sort of cut my teeth on trying to define extensions to the language that would make it usable for people in their real-world programming. And that was, I think, very true for Delphi too, where we designed object orientation into Pascal and so forth in a module system. Although that again was inspired by other implementations. I'd say C# was probably my first exposure to designing a programming language from scratch. And that was at Microsoft after I went there in the mid-90s. Well, at the time, I mean, you're thinking about, you define some big goals. And at that time, there was two ways you could go in programming, and you could have one or you could have the other, but you couldn't have both. There was either like the ease of use of Visual Basic and visual design in your desktop apps, or there was the power of and performance of C++. But you couldn't have both, and everyone wanted both. And so C# was really, in a sense, that was the overall goal. build a powerful programming language that's also easy to use. It sort of sounds simple and obvious, right? But but you know, all good things are at the core of it. And I guess, you know, when you design, yeah, you sort of try to keep an eye out for. You come to learn as you design programming languages that you can always add, but you can never take away. Because the minute you take something away, then you break people's code, and that makes them not happy. And I often say, you show me the perfect programming language, and I'll show you a programming language with no users, because those are the only ones that, I mean, you know, that because you keep learning, and then you really want to get rid of this and substitute that instead, but it's not quite the same. And so programming language design is very much, there are two distinct phases. There's version 1.0 where it's a green field and you get to do everything, and that's the foundation. And then from there on out, it's all a game of trying to shoehorn it in, you know, without like disturbing what's already there, right? And often it's a game of learning to say no more than saying yes. I mean, after we designed C#, of course, I mean, all the time people would like, we need this, we need that, we need XML literals, or we need, you know, this, that, or the other language feature. And we were always, wait a minute, it's one thing, one step at a time. And often I would say, people come to you with, when they suggest new language features, they come to you with an instance of the problem. They say, we need this, that, and we need it done precisely this way. And then it's sort of your job to discover the class of problem that they're talking about, and then implement the solution to that. So I always try to like not add language features that were just for accessing databases, for example. Instead, we added LINQ, which was about querying data in a variety of different forms. You know, it could be in a database, it could be in an XML document, it could be a graph of objects in memory or whatever. And that's sort of the class of problem, right, that you want to solve for. Yeah.
So have you ever thought about, you know, is there such a thing as a too feature-rich programming language? I think C# has done a ton of things involved and so forth. And you get these, most of the involvement, as you're saying, you know, is definitely seamless. But what about, you know, async void seems to be a misdemeanor here. What is that?
Well, but this is the price you pay for success, right? I would argue that every successful programming language is too feature-rich because it has new features that are halfway duplicative of something you could already do, but maybe not as conveniently, right? Yet that sort of confuses the novice, because which way am I? There's like three ways I could go here. Which way should I go? And you don't really learn until you're quite far down the road that maybe you took the wrong turn off. Right. But that's the price of success. I mean, like, look at all the technologies we have. Look at HTML, for example. I mean, it's like there's a gazillion different ways of styling, right? And it's a complete, like, utter incomprehensible mess. But there it is, you know, and that's what we have.
Which leads a bit to the next question. Microsoft for many years had a very corporate outlook and didn't get enough user love, so to say. Then you went open source with the Roslyn. How did that affect Microsoft, and what do you think it did to the C# language?
Well, I didn't go open source with Roslyn first. I went open source with TypeScript, the project that I'm working on now. And that was Microsoft's, I think, at least in the developer tools arena, our first foray into a project that from the onset was open source. We had other projects that had become open source, like F# predated us and became open source, but wasn't quite to begin with. And Roslyn as well, and I think then followed suit. From the onset, we wanted Roslyn to be open source, but it wasn't. Well, I guess Roslyn was, but C# and .NET wasn't at the time. So yeah, okay, you're right in the timelining there. I think it's in today's world. I will readily predict that no new programming language will be successful today unless it's open source. I mean, the date has long come and gone where it's possible to create new proprietary programming languages, and I think we knew that even back when we started with Roslyn and with TypeScript, that we're not going to get anywhere if we tell people, here it is, and you have to pay a license fee every year, and then we'll fix your bugs and release a new version every 2 years. You know, it doesn't work that way anymore. Programmers have become very empowered by open source, and you can either play along or you can take your marbles and go away. You know, that's really what it boils down to. And so we knew we had to learn to do open source. We didn't know at all how to do open source. And Roslyn was not built in an open source manner. It was open sourced, if you will, after the fact. We built it and then, you know, gave it to the community, so to speak. And there's another form of open source, which is open development, which is what we learned to do with TypeScript. We didn't do it in the beginning, but I think in 2014 we moved our development onto GitHub, and we've been there ever since. And the entire team we do everything. I mean, our design meetings, we put the agenda up on our issue tracker. We put the notes from our design meetings up on the issue tracker. The community chimes in. We're this close to our users. Every day we talk to them, right? And we know exactly what they want. They get to vote on issues, so all we have to do is sort the issues by most upvotes, and there's our feature list, you know. I mean, at least in terms of what the community is asking for, which makes it very easy to deliver happiness, right? You just go attack those. Of course, you gotta do new things too, and you gotta be innovative, but it's a wonderful way of doing business. It's very rewarding, I think, for the people involved, because you're talking to the people who use and appreciate your product every day. Mm-hmm. Yeah.
Yeah, speaking of product being used here in SimCorp, we are very heavy on C#, not as much TypeScript. And we have actually a lot of C# related questions being submitted to us that we're going to ask you if we can make the entire list.
Sure.
But before we kind of go into those questions, what exactly is your role in the C# team today?
I participate in the language design review. So Mads Thorsen took over from me about, it's close to 10 years ago now, as the main language designer for C#, and he's developed or been at the head of it since version 6, I think. But I participate. I meet with Mads every week, and like all the features that are being discussed and whatever, I end up being part of the review of that with the entire design team, and voice my opinion about it, which often is good actually, because I'll sort of come in from the side, you know, and I haven't been in, and I go, what? Or I go, oh yeah, that's great, we need that, or go, wait a minute.
So how often do you see yourself in a situation where you actually disagree or push something?
It's rare to completely disagree, but I think sometimes you can't see the forest for the trees when you're in it very closely and you're trying to define a feature and it's not quite coming together, and it's just sort of like, oh, there's this exception and that exception, and sometimes it's nice to have someone who can come from the outside and go, you know, I see what you're trying to do here, but it's not ready. Do you know what I mean? Yeah. We need to keep thinking about it. We need to refining. We need to maybe like narrow the scope of this down to something where it's really only a few concepts we're adding and not like this grab bag of overlapping things, right?
Yeah. Well, don't stop doing that for sure.
Yes. So one of the more specific ones, why does C# not support multiple inheritance?
Because I've never really seen particularly good reasons for having multiple inheritance. I do see a lot of complexity in multiple inheritance. I mean, generating efficient code for multiple inheritance is complex. There are all sorts of ways that things can conflict when you have multiple base classes and multiple overrides and and then, like doing layout and for the VM is much harder, and you end up having to inject adapters, like the VM can do it behind the scenes, but nonetheless, it's just, and even in C++, it's not particularly useful. I don't think. I mean, if you have interfaces can be multiply inherited. It's just multiple implementation inheritance that we don't support. And I absolutely, multiple inheritance in interfaces is useful. Yes, an object can be more than one thing, right? But in terms of implementation inheritance, it's just not clear to me that it's worth it's this trade-off, right? Yeah, it has uses, but are the uses worth the overhead? In my opinion, no. Yeah.
So another question is now C# is into version 10, and that means back to what you spoke about before about always being backward compatible and not being able to remove something. If you were to kind of try to describe oh my God, if we shouldn't have done that has really been the stone in the shoe since ever. If you could change one thing of the earlier versions that you do not have to support moving forward, what would that be?
Well, if I could change one thing in the design, it would probably be to have an orthogonal design for nullability and value versus reference. Today, you can have non-nullable value types or nullable value types. And you can have nullable reference types, but you cannot have non-nullable reference types. And that means null is like, you can't get rid of it when you're dealing with reference types, such as strings, right? And that's, Tony Hoare called it his $1 billion mistake, introducing null. And I think he's right. It's terrible. And and in C# we're finally delivering non-null checking. But it's not really, it's more of it's not a lint feature, but it's also not a guarantee because .NET is designed such that you can't actually guarantee that the nulls are gone, but you can catch all of the places where they could occur, but there are sort of little places where you can't really completely shut them out because of static initialization and whatever. But it is possible if you start from the beginning to design something where you can't ever see a null, and you can guarantee in your programming language that null just never occurs here. Yes, you have to do extra work sometimes, but I've become completely convinced that would be the right way to do it. It's like start out by saying all types null is not in the domain of possible values for a particular type unless you somehow include it in that domain by putting a question mark after the type or whatever, right? But don't make it be there and make it so you can't get rid of it.
So does that mean when you originally designed or was part of designing C#, you didn't have that thought at that point, or didn't you have the time to fix it, or?
I think it was just established that the pointers can be null, and there was not a whole lot of thinking about why they shouldn't be, and I think. It's also not easy if you take the viewpoint that your type system is singly rooted, then what's the difference between does a string and a nullable string, who inherits from what and whatever, and you sort of start to confuse yourself, right? And there was a very strong adherence to this notion of we're an object-oriented programming language with a single rooted hierarchy, and so. And then it's not, how do you slap something on the side then, right? Because null is really sort of a thing you opt into. So it's a shadow universe of everything else, and then it can either be that or the nullable version of that. But how do you represent that if there's a single root of everything, right? It doesn't quite work. No. So expressively, there's something in that frame of mind that's lacking. And I guess we did not go attack that. Since now, I've learned a lot, and in TypeScript, for example, TypeScript's type system is not singly rooted. It's Every type is a domain of possible values, which really is what type theory is all about. It's set theory. You're just like, you're doing set operations. You're analyzing sets of possible values, right? That's what your types are. And in TypeScript, we have union types, which allows you to union together. You can be a string or a number, or a string or a number, or null. And you put them together as you please. And then the type system sorts it out for you. Of course, that does not lend itself to, implementation-wise, this notion that everything is an object with a vtable or whatever. No. You got to go implement this differently with tagging and what have you. But once you do, you come to realize that it's a much better way of thinking about how you put things together. But that's not how we went, and so therefore, nullability has been, this long-standing issue. But finally, progress is being made with non-null checking in C#. So yeah.
So maybe jumping a bit in the questions, what did null get in there? What was the reason?
Well, I mean, it's because because ultimately, let's say, I mean, you have a reference type. A reference type is what you're storing in your variable, so to speak, is a pointer to some memory that then, and that pointer, what do you initialize it to? Well, it has to be zeroed out. Well, there's your null. Now you can either do gymnastics in the type system and the programming language to make it impossible for people to observe the null, because the null is there, right? But you could guarantee that execution never gets to observe the value of the variable before it has been initialized. So now you have to have a type checker that can do analysis of control flow analysis and guarantee initialization before you can allow access. And that adds complication in particularly like in circular instantiation scenarios. It's like, well, this one has a reference to that and that one has a reference to this, but that means that could see that null pointer over there. So now you can't really, so maybe circular data structures aren't even possible. In functional programming languages, that's the case, right? That's how they basically park null out on the side and go, no, can't be done. But you also cannot, in a functional programming language, create a doubly linked list or a tree with parent pointers, for example, if your world is entirely immutable, right? Because the parent has to have a list of all of its children, and the children need to point back to the parent, but how do I get that parent pointer back into the children after I made them, after I put them in? And so, Can't be done. So that's one way you get rid of null, right? I mean, but now you have another problem. So you can sort of move it around, right? And so it all depends. And I think there are ways, but if nullability is something you opt into, well, then, then for certain data structures, you say, they cannot be circular. Fine, but as long as you have an out, right? Right. And that's sort of where the world is at largely today. But it wasn't there with C# or Java for that matter, or C++ or any of its predecessors, right?
So that was one thing you wanted to change if you could.
Yes.
Is there something you're particularly proud of that you did?
Is there a particular feature?
What makes the most impact change you did along the way?
Well, it's funny. I mean, they all made, I would say, and that was not a change I made, that was mostly the work of others. I'd say generics was probably by far the biggest, and that was C# 2.0 and .NET 2.0, and that work was done by Don Syme and Andrew Kennedy. Don Syme, who then went on to do F#, and they actually did a lot of the implementation work too. And we kind of knew all the way in the beginning that we wanted generics, but there was not enough time to add them in .NET 1.0, so we added them in .NET 2.0. And I'm proud of the way Java has generics after the fact, but it's erased generics, where we have reified generics, or meaning that the runtime actually understands that they're generic, that types are generic, and through reflection you can see the genericity and you can instantiate generically at runtime. So you can make a list of T for some T that you discover during runtime which T it is that you want to make a list of. Now, of course, that also makes ahead of time compilation complicated. And there are, but still, I think that's a pretty cool feature. Other than that, I mean, all the work we did in C# 3.0 for Link with lambdas or and all sort of the functional capabilities that we added, the inference capabilities that are there are quite useful. I think in C# 5 the work we did with async await has been pretty impactful. Some of the other stuff has not, like the stuff if I had something to do over, I think the stuff we did in C# 4.0 with support for dynamic, I'd probably rip that out again if I could, but there it is. You don't get to take away.
So what is there, if you think about, I actually agree with you. I mean, generics, lambdas, async await, I mean, they have really changed also our lives. So thank you for that. But one of our developers asked here, can you name one of the features of C# 10 that has kind of, which one has the most impact there? And will there be any changes to lambda expressions?
Yes, well, I mean, so in C# 10, I think it is in 10, that there's natural typing for lambdas, right? Where you don't have to say a delegate type or use func of yakety yak or whatever, but rather types can actually be expressed using, a function type syntax, and lambdas are far less nominally and stringently typed. They have a natural type when you write them. And I think that's a great, that means less rigidity, less having to say types that are already apparent from the code, so. And then, I would add also all the support for non-null types, although that's sort of been spread over versions, right? But I think that's going to be super impactful, because we really do allow you now to solve the null problem, the $1 billion mistake.
Yeah, another one we have here is, part of your C# experience, which part of the C# experience do you think have had the most impact with your TypeScript work?
Well, I mean, I think coming to TypeScript, originally, one of the reasons we did TypeScript was, when we started TypeScript, remember this is 10 years ago now, and JavaScript was a very primitive language at the time. It didn't have a module system. It didn't have classes. So that's going back to ECMAScript 5, right? And so our experience doing object orientation and whatever from C# definitely helped in guiding us to how to design like classes and an idiomatic way to generate code for them in JavaScript. Later, classes became an actual language feature in JavaScript. They are now, but they weren't at the time. And so we had to do transpilation of classes into some other something code that we generated. When you wrote class blah blah blah, we would generate a constructor function, and with there are certain patterns that you can still use and that classes internally compile to or get code gen to. But I think that helped. I mean, I think just having done language design before, I think also like this. Having been pondering this question of how do you solve the nullability problem, right? Because I full well knew that it wasn't solved in C#, right? And how do you solve it, And in TypeScript, that was a journey. In the beginning, we weren't solving it, but then we learned more and more, and I'd say today we fully solve it, and it's awesome. People love it. Yeah.
So coming back to one of the other C# questions, why are finalizers in C# not guaranteed to run, even when finalization is not suppressed?
Well, it depends on the garbage collector, right? And the garbage collector is non-deterministic. Is that what you're getting at, or I mean, it's if an object is never collected, then the finalizer never runs. So if you have a dangling reference to something, then that object will, the collector will never collect the object, and therefore the finalizer will never run. And the time at which a finalizer run is also non-deterministic, which is what makes them poisonous, if you ask me. I mean, because you have no idea when or even if this dang finalizer is going to run. And so that makes it very hard to reason about what can I do in here. You know, and typically, and what makes it even worse is that typically finalizers clean up externally held resources, say such as file or database handles or what have you, right? And now it becomes non-deterministic when you close your files or when you let go of your database connection, and that's generally a very bad thing, right? So my advice is avoid finalizers at all costs, because they are non-deterministic and really generally a bad idea. And then if you revive an object during the finalization phase, now you will not get a second chance at finalizing. So it's just don't go there. There's nothing but pain.
I think we also long time ago went with the, deterministic is actually what you need, and then go with the disposed pattern instead.
Right, exactly.
I guess it's also the fact of having finalizers running, at least in the old days, on a single thread, and if that hung, then the remaining wouldn't go.
But
you already said it. Don't go there. That makes
that's add another pitfall. Yeah.
The last C# question. So, will there be a C# version 20? Now we have version 10. Or do you think Java and TypeScript at some point will make C# irrelevant?
No, I don't think so. I mean, for God's sakes, COBOL is still relevant, right? And Fortran, I mean, maybe not as relevant as they once were, but they're still relevant. And nothing in this world goes away, I think is what we keep proving to ourselves, right? That programming languages evolve very slowly. I mean, look at the programming languages we're coding in today. They're not that different from what we had 50 years ago, right? They really aren't. And part of the reason is that they are much more connected to the human in the equation than they are to the hardware. They are the thing that the human uses to communicate with the hardware, right? But massive advances in hardware have not commensurately led to 10x or 10 or 5 orders of magnitude improvement in programming languages that we've seen in hardware, right? So I would expect that to remain the same, because our brains have the same size still. So progress is made slowly and iteratively, and it's getting increasingly expensive to start from scratch, right? Because expectations are ever increasing and capacity is ever increasing, and back in the good old days with 64K or even 640K, you just throw it all out every year and start over, right? I mean, and write a better one, and that was kind of fun. But those days are gone, and they every year they're further away, right? So we have to find ways to leverage, and that means that I think typically starts with finding ways not to rewrite. I mean, that's the business you guys are in, right?
Now you just reminded me of the fun days of being able to rewrite every year. That was fun for sure.
So I wouldn't be surprised if C# 20 someday comes about, and hopefully I'll be around to see it.
We hope so.
Yeah, so moving a bit out of the C# questions, do you work in an agile way? And if you do, what is agile to you?
Well, agile to me is doing the open development, GitHub, open source workflow, and I would argue we're very agile. I don't know if we adhere to, if there is an official thing called agile development, whether we adhere to that, but certainly our team is very agile. The TypeScript team ships new versions every 3 months on a set cadence. And we have a whole workflow for how features go into the product. We do nightly builds that are installable by all of our users and guaranteed to work, basically. We have an enormous test suite that we run, and so our nightly builds are highly stable, and people pick them up and use them. So in a sense, we're perpetually in beta, you know. And people will often take the nightly because we will often fix a bug for them that goes, oh, all of a sudden the type checker, you know, like took 3 times longer and then we discover, oh, okay, we need to fix this, and then we fix it, and then the fix is always in the nightly. The minute we merge the PR, the fix is in the nightly that night. And then people will just pick it up and then they'll go with that because, you know, it's stable enough. So we often see overnight turnaround on issues that get reported. And like I said earlier, you know, we have a very, very close communication with our community, and so we're very aware of what our users want and how we can deliver it. So yeah, it's a wonderful way to work. Plus, and of course, being entirely cloud-based in your workflow too means our team can be geographically dispersed. So when this whole pandemic happened, it literally did not disturb our workflow one bit. Nothing changed.
Nope.
Well, our design meetings were no longer in person, they were over Teams, right? But they kind of were anyway, because some of our team members are not in Redmond, and so they would call in. And now the default is just that the virtual is the default, and you can go and sit in a conference room if you want. I haven't even been to campus for 19 months. I have not seen my office, so I'm still working at home. Yeah, and I will never go back to the same workflow as before, right? And we never will.
No, yeah. I believe you're right.
Yeah.
But probably would change. You talked about the basic gated check-in, a lot of testing and so forth. And there's a very specific question here, which I'm very interested to hear your answer to, which is what is your view on victory of testing over formal specification and verification techniques? Put otherwise, do you believe in I will prove anything or everything works, as opposed to I will test and see if I can find bugs?
It has to be a combination. There is no known programs. So we all have to realize that programs, at least of the complexity that you have to have in order to make a real world product, it is never provably possible to determine whether they will work and whether they will halt and whether they will deliver answers in time or correct answers. I mean, you can get close, and type checkers, there's one way, and formal, there are other even more advanced ways of checking your code, but it's always an approximation. It is not, an absolute proof is literally, did the kind of code you would be able to write that you could absolutely prove things about is uninteresting at best, and not real world. So you want a combination of static testing and through verifiers and type checkers and through tests that you write, because you know what are the usage patterns, right? I mean, that's the thing that a compiler cannot see, really. It's like, how is this supposed, and so it has to be a combination. I don't think there's any victory of one over the other.
But do you then see, because I think, do you then see an evolvement here that will have more of the proof thing? Because one thing I'm thinking about here is, for instance, the help from the compiler. You can't use this variable before you assigned it, or the nullability we talked about before. You can prove that null is not observable or never there, or whatever. And could you imagine having, going forward, there'll be much more of that you can do statically, which will then drive earlier feedback, which is good for everybody.
Yeah. No, that's like, if you look at how TypeScript has evolved, it's like we keep making the type system more expressive, and we keep being able to find new classes of issues that we couldn't find before. But it's imperfect.
Right.
But that's the funny thing about, and in a sense, it speaks a bit to why our work with TypeScript has become so popular, because like the classical view of type theory has been it's either sound, provably sound, or don't bother, right? And that's a fallacy, because if you can get like 90% there or 95% there, and it's still a Swiss cheese, there are still holes, but if you understand where the holes are and what their effect is, there's tremendous value in knowing with a high degree of certainty that this isn't null. That's a hell of a lot better than not knowing at all. And that was sort of before, if you couldn't guarantee it to me, then do nothing. Well, So type checking used to be a switch, and I often say, and TypeScript's turned it into a dial. And you can dial it up or down as much as you want with this gradual typing that we do, and it's tremendously useful. And I think there's another angle to it that people forget, which is type checking is a deep enabler for tooling.
Yes.
And that is why TypeScript has become the success it has been. It's not. I mean, it's wonderful that it can tell you that this might go wrong and that might go wrong and this and here's possibly an error, right? But what's even better is that it can deliver for you a statement completion of here's what could come here, right? Or it can narrow your type based on control flow analysis and show you that now you've eliminated the string case, so you must have a number here, where up here you had a string or a number, for example, right? It can do safe refactorings because it can tell the difference between X and X, in two different types, right? And only rename that one and not the other one, which, like, otherwise, how can you do this, right? And that is, I mean, people tend to forget, but it's always very funny to observe programmers if you take away their IDE and you make them try to write code. And, this is going great until dot, and then nothing happens, and then, geez, now what? Right? And and dare I run this? I mean, I don't know. I mean, how would I know if this is going to work, right? I mean, so type systems, it sort of switched from being, it used to be something you had to do so that the code generator could generate efficient code, but it's become much more important for tooling's sake and productivity's sake.
So speaking also about tooling, how do you see the future of ML.NET and AutoML, and do you plan to do any tooling for that, similarly to what Apple has done with Xcode?
Well, I know that we are doing tooling. I'm not involved in that work stream, so I can't tell you a whole lot about it, other than I know that we're investing in it heavily. I mean, like everybody is investing in ML and AI, right? And it is a big workload for Azure and for our customers. But that's, sort of the depth of my involvement with it, yeah.
So there are things you do not know.
Absolutely. Lots of things I don't know.
There we go. So looking back at all the languages you work with, and I'm thinking all the way down to, remember BLS Pascal was actually the first one, Compass Pascal, Poly Pascal, Turbo Pascal, Delphi, J++, J#, F#, C#, and now TypeScript. I don't know if I forgot anyone here, but of all these languages, which one is your pet language and why?
That's sort of like asking which of your children do you love most, right? I mean, that's you can't answer that question. They're all great. They were all fun in their own way. I just love working on programming languages, And I think the work we're doing now with TypeScript it's fun because I'm learning new things, right? And that's what makes it interesting. And I feel like with every product I learned something, new. And that was what made it fun. And continues to be true.
It's a fair answer.
Yeah.
So we talked about some time ago that programming languages tend to stay around. One of those that's staying around with us is APL.
Yep.
But we're also moving into the cloud, so people need to learn more about C# in our case. Do you have any tips, tricks, suggestions? How should a skilled APL developer learn more about C#? Or how could they?
Well, those two languages could hardly be more different, right? So I mean, I can't say that I have tips for APL programmers specifically, and I think, I mean, your company probably represents a large portion of the world's APL's programmers by now. I think it speaks a little bit to what we talked about earlier about sort of the cost of rewriting everything is tremendously high, right? So you got to find smart ways of continuing to use APL in a sandboxed, controlled fashion, right? And control its runtime environment to make it as efficient as possible. And then invest in building the rest using more mainstream development tools, right? And I would imagine that over time you guys are going to end up doing more browser-based stuff than you're probably doing now. It's amazing what you can build today, and in terms of deployment and maintainability and whatever, it's just like there's so much work that has gone into making that completely friction-free, right? And so there's a reason that almost, I mean, like the web is like the platform for modern apps today, right? And I mean, I continue to be amazed at what you can build in the browser today. And now with WebAssembly, my God, you could even run APL in there, you know. I mean, it's kind of crazy, right?
Oh, we are definitely going in the direction you're suggesting, also into the web eventually, for sure.
Yeah.
So we talked about a lot, not today, and you talked about your work with TypeScript, but you know, 10 years since you kind of left the C# group actively. So what have you been doing those 10 years, and what is your, you know, what's next? Are you going to work with TypeScript for the next 10 years, or
yeah, who knows?
What's your
well, I got interested in it's funny because with C#, my function there was, I was the language designer, and that meant writing a lot of specs. But it didn't mean writing a lot of code necessarily. Early on in the .NET days, I wrote a lot of, my code writing was done on the framework side. So I wrote a whole lot of the base classes that are in .NET. Like having to do with streams and the string class I worked on, and like stuff like that, right? That was, and then the whole link thing I worked on implementing all of that. But more and more it became sort of, right, you know, as you advance in your career, you become this architecture astronaut. You know, you're up in the sky, and you know, you're so far away from what used to make you happy. And I was gradually feeling that, you know, I was just not as fulfilled in my daily existence. And so when this TypeScript opportunity came along, it was, well, we didn't know it was an opportunity, but there was a problem there, right? Like people were trying to write very large apps in JavaScript and failing miserably. And we were kind of going, why is that? And they were suggesting, like, I mean, I think sort of part of the genesis for TypeScript was a team came to us with this translation tool called Script Sharp that would translate C# into JavaScript so you could run it in the browser. And they had a whole sort of adapted class library that allowed you to pretend that you were writing C# code, and you could use all the C# tooling. And then it would cross-compile to JavaScript, and out would come this like mungled mumbo-jumbo, and you would just treat JavaScript as your IL.
Yeah.
And I was like, really? Is that how development is going to look in the future? I don't think so. Wouldn't it be much better? It's like, what's the problem with JavaScript? Why don't we fix that? You know, surely that's going to be better. And so that's what got us started. And at that point, I was like, and then we wrote, our team wrote a compiler and whatever, and I was sort of still doing the language design. But then there was a part of me that sort of saw an opportunity, because the compiler we wrote for the first TypeScript compiler was, well, we need to write a compiler. Let's take some guys who know write compilers. Well, we got some of those on the C# team. And then so in they come and they proceed to write a C# style compiler in JavaScript, which is not how you're supposed to write JavaScript. it had all sorts of auto-generated ASTs and classes and whatever. I mean, we had like 25,000 lines of code before we even wrote any code. Do you know what I mean? And that doesn't work so well in a browser or in a web scenario, right? And so, and there's a different way of writing JavaScript that's much more functional, because JavaScript was designed originally by Brendan Eich, and he had a strong background in Lisp and functional programming languages, and the one thing he got right, there were mistakes made in JavaScript, no doubt about it, but one thing he got right was first-class functions, the notion that functions are objects that you can manipulate, and so first-class functions and closure over state, where inner functions can access the local variables of their containing functions, and you can create closure over those local variables, which was something that came later in C#, right, with lambdas, but wasn't there in the beginning. But the fact that those were there means that there's a style of functional programming you can do in JavaScript that is much more lightweight and much more efficient from a VM perspective. And so I started experimenting with that, and I started writing a compiler. And let me try to write a parser and a lexer and a scanner and see how does that feel to write that kind of code. And it turned out, felt pretty damn good, and it was like 5 times smaller and 5 times faster than this C#-ish thing that we had created, right? And that then became the new code base for the compiler that we're in now. We decided to switch to that code base, and we're still on that code base. And interestingly, there are no classes in the TypeScript compiler at all. The TypeScript compiler, the type checker is one function called create type checker. That's 40,000 lines of code, with a bunch of nested functions in it and a whole bunch of state. It does a whole bunch of lazy eval and immutable data structures and whatever. It's a very different way of programming. All polymorphism, if you will, is done through switch statements, which is more like which is sort of like like math or like pattern matching in functional programming languages, right? And there's complete separation between code and data. There's no intermingling of the two, and so in that sense, that has kept me happy, right? Because I got to write a whole bunch of code and learn a whole bunch of new things, and it's been a lot of fun. And that ultimately is, I mean, that's what life's about, right? I mean, you want to be happy with the work you do. And so as long as I'm happy with the work I do, I'll keep doing it.
Yeah. I got to ask the last question. So I need you to tell us a story from the old days. And what I'm looking for here is one of those rare stories where you kind of get this aha moment. And I can tell you one where I experienced you having an aha moment. And that is all the way back to both our first steps into programming. I mean, maybe the audience doesn't know, but the fact was I started programming before he did, but he did better than me, obviously. I don't remember, we're kind of in the beginning.
Yeah.
But what is your aha moments, if you were to give a story from the old days, or maybe new days, aha moment?
I think, first of all, I think there are aha moments all the time, which is what makes it fun, right? I mean, and it's true. You'll get an idea in the shower, you go, oh my God, I just realized how we could do this like super cheaply, right? With what we already have by thinking about it differently, right? You never know when these ideas are going to come to you, But early on, since I was very much, and you were too, we were very much self-taught programmers, right? I did go to school to DIA, or Danmarks Ingeniør Akademi. They no longer exist. It's part of DTU now. But I ended up dropping out after 3.5 years because it was either finish that, or do the startup, which was Borland basically, and I chose the latter. But in many ways, it meant that I did not really have a particularly solid foundation in the theory of programming and programming languages, and there wasn't a whole lot to be had. And so when I wrote the first version of Turbo Pascal, for example, well, I sort of well, you come to realize when you're writing a compiler and you have to deal with like variables and look them up, you have to somehow have a way of looking them up, right? So you have to have symbol tables, right? So how do you organize those symbol tables? I don't know. You know, I mean, I guess we'll have like all the ones that start with A go on this list and all the ones that start with B go on that, or well, that's too expensive. Maybe we'll just like have a linked list or something, you know, and in fact, Turbo Pascal 1.0, its symbol tables were linked lists. Which is great if you have 4 local variables and sucks if you have 100, right? Because lookup is incredibly expensive. And then I remember buying and reading the book called by Niklaus Wirth called Algorithms plus Data Structures equals Programs. And one of the things he talked about was hash tables.
Yeah.
I'm like, hash tables? What's hash tables? I'm going to start reading about it. Holy shit, what? You can, let's try that. And so I put it into Turbo Pascal, into the compiler, and boom, it went twice as fast. So from Turbo Pascal 1.0 to 2.0, I learned about hash tables, and that made the dang thing go twice its speed, right? So that was very much aha. So, but it's like that, right? You learn all the time.
Yeah.
Yeah.
Thank you, Anders, for spending time with us, and thank you to all the SimCorp developers for submitting these great questions for this software engineering day with SimCorp. And
yeah, you're welcome. It was fun.
Thank you.
Mm-hmm.